Hello and welcome back. In this video, we're going to look at iteration with for loops and generators. You have already seen how to print out each element in a list or a dictionary, the key value pairs, by using a simple for loop. So let's look at how we can use a for loop to give me the sum of all the integers in this list. How would we go about doing this? Well, we can start a variable sum, set it to 0 to start, and then we can simply iterate through each element in the list and keep adding that to our sum. So I can say for num in L, sum equals whatever the sum was before plus num. Okay, so let's look at what this is doing. I'm setting sum to 0, so initially sum is 0. Then for num in L basically says run a for loop in this iterable right here, which is L, which is my list. And the first time num is going to be 6. The second time num is going to be 8. The third time num is going to be 1. And it's going to keep going till it gets to the last element in the list. So sum in the first case is 0 will be equal to sum plus num, sum which was 0 plus num which is 6. The second time, sum equals sum plus num. So sum is 6 plus num, which is this time 8. So that's 14. Third time, sum is 14 plus num is 1, 15, and so on. It'll go all the way to the end. So this is how you might be able to get the sum of all the integer values in your list. And to print this out, I'm going to print this out outside of my for loop block. So it only prints out after the iteration is complete. I can simply say sum using list and then the sum. Okay? If I run this, sum using list 63. So that's the value of all the integers in my list added up. All right. Now, what is a different way of running an iteration? For example, this one is running on this iterable, which is our list. We don't really have to use an iterable to do this. For example, we know our list has 11 elements. I can run a for loop. All I will need to do is provide an iterable that has 11 numbers in it, or potentially 11 numbers in it. How do we do that? We can use the range function for this. A range function is a generator that gives you an object that you can iterate through. And the range generator is a quick way to generate numbers. Let's take a look at how it works in the console over here. I have a new tab open on the side and I have my Python console going. And the way to use it is, let's say range, and then I'll give it a number. This is going to give me a range object between 0 and 10. This is simply an object. This is not the list of numbers. To turn this into a list, what I can do is cast it to a list. So list and then range 10. And you see it gives me 10 numbers between 0 and 9. In prior versions of Python, if you did just range 10, it would give you the list of 10 numbers, but that's no longer the case. All right, so if I save this, let's say my list equals underscore and my list. And this is a shortcut, just so you're aware. It basically says assign it whatever value I had in my previous line in the console. So this essentially means my list equals list range 10. If I look at the type of my list, you see this is now a list of 10 numbers. But if I look at the type of range 10, you see it's a class range, which is a generator. And it's important to distinguish the two. And we're going to look at more generators later on. So you see we were able to generate this list of numbers. If I use this functionality here, I can say for num in range 10, which is what we used here, if I do print num, and if I run this, let me code this out. Check it out. It gives me the 10 numbers. All right. So instead of printing out each number, what I can do is perform some function each time. I can, instead of printing out the number, I can just say print hello. What does that do? It'll simply print out hello 10 times. Similarly, you see these starting at 0 going all the way to 9. See how easily they fall into the indices of my list. For example, 0 is the first element, 1 is the second element, and so on and so forth. So I can easily use this to reference each element in my list at every iteration. And if I did that, then instead of saying print hello, I can say print L, which is my list name, at num, which is my index. If I do that, clear this up, let's run it. You see, it gives me the same result of all the values or elements in my list as in this case. So if you wanted to grab the first 5 numbers, you can say range 5. And then if I run that, you see it grabs the first 5 numbers. So if I were to use range to find the sum, then I would need to know how many elements or numbers there are in my list. And that, I can get using my len function. So if I do len of L, that essentially is saying range of however many elements I have. I think there's 11 here. So range 11. And instead of printing the value at that element, what I can do is use this notation to calculate the sum. So sum equals sum plus L at num. All right. And I'm going to have to reset sum here simply because I'm working with the same variable sum here. Otherwise, it would just add on top of it. So after I do that, let me print out this value. There you go. Sum using range generator, and then I will uncomment this, sum using list. Okay, if I run this, there you go. We get sum using list, sum using range generator, 63 on both occasions. So this is something you will find a lot in code, because you may not have the list or values predefined. Let's say you're asking the user for input, then the user is going to provide that number and you may have to run something that many times. So you will not have an iterable like a list to do that. You may also need to deal with half of a list or perform some function using only half of that list. Then this is very useful, and we're going to see that in the algorithm section. Now, one thing I want to point out is sum equals sum plus num. This notation is very common and used all the time where you're incrementing the value of a variable using its existing value. You can write the short form for this and basically remove this part and simply say sum plus equal to num. Same here, sum plus equal to L at num. If I save it and run it, you'll see the same results. Perfect. Now back to what I was saying about not knowing how many times you may need to run something. And we're going to see this in our algorithm section as well in the project, where we ask the user how many times we want to run a performance test. In that scenario, you're going to get the input from the user, and this is what it's going to look like. I'm going to get rid of all this. There you go. So I have this variable runtimes equals the in value, and I'm asking the user for input. How many times do you want to run the program, let's say? And the way you would do something like this is you have this runtimes available to you. So for num in range runtimes, you can say print f run number and then provide the number. But one thing that's going to happen here is that runtimes range, as we saw, goes from 0 to the number here, not including the stopping index. If you're trying to show the run number like this, you're going to start with 0 and you don't want to have a run 0. So I'll just add a num plus 1. Okay. And if I run this code, how many times do you want to run? Let's say 5. There you go. Run 1, 2, 3, 4, 5. If I did not provide this plus 1, then it would start at 0 and go to 4. There you go. And you don't want to have a situation like run 0 because that doesn't make sense. Okay. Now, before I move on to working with the dictionary and iterating through it, I want to mention something else about the range function or the range generator and how it works. So far, I've been providing it the stop value, and the start value has been 0 every time. but you can provide the start value as well. So you don't have to use the default 0. For example, I'm going to go to my Python console. Instead of doing range 10, what if I started at 0 and went all the way to 10? And of course, I have to cast this to a list to print it. If I do that, see, it goes from 0 to 9, but this is done by default. Now, I can change that and say, instead of going from 0 to 10, go from 1 to 11. Then you see it starts off at 1 instead of 0. I can also provide a step size as the third argument to this. So let's say 1 to 20, and then step size of 2. So print out all the odd numbers between 1 and 20. And you see 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So range, as you can see, is a very useful and powerful generator and is used in a lot of places in Python. Okay, so now let's move on to working with this dictionary. I'll go back to the other screen in my terminal, clear this up. All right, so we used the items generator before in order to iterate through in our simple for loop for dictionaries. Let's see why we did that. Okay, so if I do for item in my dict, let's say, and simply print out the item, my dict, remember, is my iterable in this case, which is the dictionary. If I ran this, then you see it only gives me the keys, pi, rb, and js. So that's why we used mydict.items, because if I print out mydict.items, then you see we get this iterable of dict items. For each key value pair in my dictionary are turned into a tuple. Therefore, if I take this iterable and place it in place of just the mydict dictionary reference, so now we have this iterable that has these key value pairs for each of them. So if I save this and run it, then you see I get each of the tuples. So Py, Python, RB, Ruby, JS, and JavaScript, and each one is a tuple. Now remember from our video where we looked at tuples, we can unpack tuples. So if item is a tuple, then we can say key and value equals item. And then I can print out key is key, and then value is value, right? And this is an F string, so I have to put the F in there. Okay, if I did this, see item at each time being the tuple, key is going to get the first item in the tuple, and value is going to get the second one. So if I ran this, check it out. I'm able to use the key and value separately. And instead of doing it here like this, what I can do is simply copy these two and do the unpacking in this for loop itself. All right, so then I don't have to do it here. That way, I have access to the key and value right away. If I ran this now, check it out, same thing. Perfect. And you will only be able to do this, which is unpack tuple values like this, when you have an iterable that's actually giving you tuples as the object. And if items actually gave you, let's say, tuple with 3 values in it, then you could use something like this. You could actually unpack the third one as well. But that's not going to work in this case because we only have 2 values in our tuple. Okay. And the last thing we're going to look at in this video is we're going to take a look at list comprehension and how that works. So let's take a look at our problem statement. We are asked to generate 100 random integers between 1 and 100. Now, when you're presented with a problem like this, you may be tempted to write a for loop, a regular for loop like this, for num in range 100, which is the iterable, so 100 times. Let's say we have a list and we want to append something to that list. So let's start an empty list, L1 equals empty list, and then L1 dot append will append a random integer over here. And to generate a random integer, we can use the randint function provided by the random module. So I'm going to import random over here. Actually, I won't import it directly. I'll say from random import randint. So basically, from the random module, I have access to this randint function. So what I can do is say randint between 1 and 100, okay? And then let's print out L1. If I do this and run it, you see it works. I get my list of 100 numbers. But when you have a scenario like this where you are generating numbers in a list in an orderly way, what you can do is use a list comprehension instead. And the way to do that is, see here where I'm starting off my empty list, I will place this for loop notation in there. So for num in range 100, I'll place in here, okay? For num in range 100. And then in my for loop, you see I'm appending this randint between 1 and 100. So a random integer that's generated. And since list comprehension is a quick way to generate lists, this append is implied. So what I simply need to do is provide the value in the beginning for what I want the list to include. So this is the part that's important, that's doing the generation. I'm going to copy this and then paste it here. Okay? If I save this and actually get rid of my for loop entirely and run it, check it out, same result. All right, I get my list of 100 random integers. And this randint 100 can be anything. For example, I can simply get the num in my list as well. This will give me 0 through 99 or 100 elements. I can even get the square of those elements. So num to the power 2, 0 square, 1 square, 2 square, 3 square, and so on. And you're not necessarily limited to just numbers. You can generate lists of other values as well. For example, if I wanted random lowercase characters over here from my alphabet A through Z, I can use that. So for that, I'm going to get the ASCII lowercase constant. So from string, import ASCII lowercase. I'll also import the choice function from random. And what choice does is whatever you provide it, it just randomly chooses an element from there. So from my ASCII lowercase, I want to randomly choose a character. I can simply say choice ASCII lowercase for num in range 100. If I do that, check it out, I get 100 random character choices between A through Z in my list. And that's list comprehension for you. All right? So that's a lot we've covered in this video on for loops, list comprehension, and generators. Hope you enjoyed it. In the next video, we're going to look at more iteration with while loops. See you there.